In today's battle for the electric vehicle customer, power is everything. And the driving force behind the power is the EV battery, which is the single most important factor determining all the electric vehicle specs, such as how many miles you get, how long it takes to charge, and if you're going cross-border, can it make it to the next charging station? Because the battery is at the heart of every fully electric vehicle, the battle between battery swapping and supercharging is super interesting, because both options have advantages as well as disadvantages, which we'll discuss in today's video. BYD Blade Battery. In March 2020, BYD unveiled its Blade battery. With it, the company hopes to completely eliminate EV safety issues like battery fires. Wang Chuanfu, chairman and president of BYD, referred to the Blade battery as a quote-unquote gift to the industry, indicating that the company is willing to share it with other automakers. In the future, we will share a lot of our technologies and products to the world, Chuanfu said at the Blade battery unveiling last year. The Blade battery's proprietary design is shaped like a sword or a saw blade, with positive and negative terminals at each end. Although a saw blade can be easily flexed from side to side, it is rigid when bent up and down. This is the same concept that allows the individual Blade battery cells to act as structural support within the battery pack. When installed in a battery pack, honeycombed structural panels provide adequate support for the battery pack. According to BYD, each long blade battery acts as a support beam, adding strength to the entire pack. The Blade battery was also designed to make the best use of the battery pack's available space. According to BYD, the Blade battery uses more space than a standard EV battery. Each and every blade is 96 centimeters long, 9 centimeters tall, and 1.35 centimeters wide. The single cells are arranged in an array before being inserted into a battery pack. This design is known as the cell-to-pack technology, and it eliminates the need for individual battery modules within the pack, each of which requires their own thermal management system and electronics, so yeah, saves a lot. When compared to conventional cylindrical lithium iron phosphate batteries, this configuration makes better use of available space, resulting in a higher energy density, as more cells can fit. Another issue addressed by the Blade battery is safety. The combustion and explosion of lithium-ion batteries is one of the most serious issues impeding the development of the EV market. Overheating batteries have caused battery fires in Tesla, Hyundai, General Motors, and NIO Inc. vehicles. However, as EV adoption grows, so do the risks of battery fires, unless EV batteries can be made safer, that is. Hyundai announced in February that it was recalling approximately 82,000 electric vehicles to replace battery packs that posed a fire risk. The recall is one of the automaker's first major recalls of electric battery packs. The recall of battery packs is expected to cost around $900 million, according to Hyundai. The cathode material in the Blade battery is lithium iron phosphate, LFP. According to BYD, it provides a higher level of safety than conventional lithium-ion batteries, as well as superior strength, range, long life, and power. Even temperatures as high as 500 degrees Celsius, LFP is safe and stable, and it operates, which is kind of nuts. The Blade battery also passed an extreme strength test in which it was rolled over by a 46-ton heavy truck. The national standard is a little less stringent than the heavy truck test, though. The battery passed the test with no leakage, no deformation, and no smoke. According to BYD, the Blade battery pack was completely intact head to toe and ready to be used in an electric car. BYD also claimed that its battery withstood other extreme test conditions, such as being 260% overcharged, crushed, bent, and heated in a furnace to 300 degrees Celsius. There was no fire or explosion as a result of any of these tests. According to BYD, the Blade battery is the only EV battery in the world that can actually safely pass these tests. BYD has 26 years of battery research and development experience. The Blade battery design and manufacturing line were created entirely in-house. BYD stated that it is currently increasing the production capacity of its Blade batteries. According to the company, some of the auto industry's key players are starting to rely on this ultra-safe battery technology. As leading global automakers collaborate with BYD subsidiary FinDreams Battery, the Blade battery will gradually be installed in EV models from mainstream brands like Tesla. Yeah, big T. According to unconfirmed Chinese reports, Tesla is already C-sample testing the BYD Blade battery for a more affordable model that is in the works. It could be used in Tesla's electric vehicles starting as early as 2022. The BYD Han, which established itself in China's mid to large luxury electric sedan market, was the first BYD model to feature the Blade battery. In China, the Han is a direct competitor to the Tesla Model S. Since the Han debuted in January of 2020, BYD sold more than 10,000 units a month. It has a range of 375 miles and can accelerate 0 to 60 in about 4 seconds. BYD is actively participating in China's efforts to significantly reduce carbon emissions by 2030 and achieve carbon neutrality by 2060. BYD believes that using Blade batteries in all of the company's future electric models will actually make EVs safer and help to accelerate the global pace of vehicle electrification. That sounds like an evil scientist's mad plot, but in reality it's just something good that we all want. And now we're going to talk about NIO's battery swap tech. So what exactly do we mean when we're saying swapping versus charging? Elon Musk is a name everybody's familiar with. He's a dude that runs Tesla, the world leader in electric vehicles, with one of the best and most innovative battery systems, ? Since its inception, Tesla has been obsessed with creating a better battery and faster charging system, which has resulted in a global infrastructure of Tesla's supercharging units that can currently charge a battery up to 80% in about 40 minutes. As a result, Tesla has single-handedly transformed the EV landscape, offering increased mileage and faster charging times while producing stunningly beautiful vehicles at the same time somehow. NIO recently launched Battery Swapping 2.0, an ingenious, if I do say so myself, system for replacing the entire battery in a car with a new one, where the entire process is automated. Simply activate swap mode, and the car's autopilot will work with any swapping station to park the vehicle. In just 4 minutes, it removes the current battery and replaces it with a fully charged one. So at this point, it's pretty easy to say that NIO has clearly won the battle, because 4 minutes for a fully charged battery versus 40 minutes for an 80% charge is kind of a no-brainer. But things are obviously a little more complicated than that. For the time being, swapping out beats charging hands down. But if you look at a more practical everyday use, you would most likely be able to get anywhere you wanted to go with less than 200 miles of battery power, and you'd only need a charge for about 15 minutes to achieve this range. So, as you can very plainly see, charging and swapping are now just a little closer together for everyday use, but more importantly, the networks vary greatly in size. Tesla has over 25,000 superchargers in the United States and over 6,000 in Europe, and they're rapidly expanding the network all over. Simultaneously, NIO only has 200 swapping stations in China and is collaborating with Sinopec, the country's largest gas station owner, to deploy 5,000 swapping stations over the next couple of years. So basically that's where Tesla's got the advantage, because even if your technology is faster, it won't matter if you can't access the swapping technology. This 5,000 swapping station deployment schedule also highlights a key issue in the battle between swapping and charging. In the time it takes NIO to deploy more swapping units, Tesla will release newer batteries with greater range and faster charging times.